about stack. If you are new here, do not forget to like, subscribe and turn on the notification bell. Today's tutorial is about graph representation and we will mainly focus on the adjacency matrix. In this video, you will learn how graphs are stored in memory, how vertex and edges are represented, and how an adjacency matrix works with clear examples. Let's begin the lessons and understand graph represented step by step. First, let's understand what is a graph. A graph is a data structure used to represent complex and non-linear relationships. A graph is made up of nodes, which are also called vertex, and those nodes are connected by edges. A graph has two main components, vertex and edges. Let's talk about vertex. Vertex are the fundamental unit of a graph. They represent data point or object in a graph. Vertex can be labeled like A, B, C, unlabeled depending on the graph. Now let's look at the edges. Edges are used to connect the two vertices. They show the relationship between nodes. Edges can be directed, meaning one way, or undirected, meaning two way. This can be also called labeled or unlabeled. Now let's talk about the type of graph. A graph can be categorized into different categories based on properties such as edges direction, connectivity and other features. First we will look at type of graph based on edges direction. There are two type graph, undirected graph and directed graph. First look at undirected graph. An undirected graph is a graph where edges do not have any direction. In this type of graph, the connection between nodes is two-way. This means the nodes are unordered pairs in the definition of every edges. For example, if there is an edges between A and B, you can go from A to B and also B to A. Next one is directed graph. Directed graph is a graph where each edges has a direction. In this case, the connection is one way. The nodes are ordered pairs in the definition of every edge. For example, if there is a directed edge from A to B, you can go from A to B, but not from B to A, unless there is another edge. Now let's continue another classification of graph. Now we will look at types of graph based on weight. There are two types, weight graph and unweighted graph. A weighted graph is a graph where each edge has a weight. This weight represents values such as distance, cost or time. Weighted graphs are commonly used in math, networks and routing problems. For example, the distance between two cities can be shown using weight of edges. An unweighted graph is a graph where all edges are treated equally. There are no extra values like distance, cost or time on the edges. Here edges only show whether a connection exists or not. Unweighted graphs are often used when all connections have the same importance. Now look at the animation video. Now let's talk about graph representation. There are many ways to represent a graph in our computer memory. Graph representation means how we store graph data inside the computer. The most commonly used graph representations are adjacency matrix and adjacency list. Adjacency matrix is a square matrix used to represent the finite graph. Each rows and columns represented vertex of a graph. If there is an edges between two vertex, the value is sorted in the matrix. An adjacency list is a data store, a list of its neighboring vertex. In this video, we are going to talk only about the adjacency matrix representation. There are different ways to represent a graph in the memory, but this video focuses only on the adjacency matrix. What is adjacency matrix? An adjacency matrix is a square matrix of size n by n. Here n is the number of nodes or vertices in a graph. This matrix is used to represent the connections between the vertices of a graph. If there is a connection between two vertices, the matrix stores a value to show the connection. Adjacency matrix can be used for both undirected graph and directed graph. In the next slide, we will clearly explain undirected graph and directed graph, how adjacency matrix work for each type. So make sure to watch the next slide to understand those concepts easily. Now we are going to see how undirected graph represented using an adjacency matrix. We use adjacency matrix to represent connection between vertex. Initially, the entire matrix filled with zeros, meaning no edges exist. There is an edges between vertex 0 and vertex 1, so we said met 0, 1 equal 1 and met A 0 equal 1. There is an edge between vertex 0 and vertex 2, and so we set mat 0 2 equal 1 and mat 2 0 equal 1. There is an edges between vertex 1 and vertex 2, so we set mat 1 2 equal 1 and mat 2 1 equal 1. Now the adjacency matrix represents all the undirected connections clearly. Now let's see an animated example to understand this better. Going to see how a directed graph is represented using an adjacency matrix. First step is start with an empty matrix. Initially, the entire matrix is filled with zeros, which means no edges exist yet. Second step, add edges. Like an undirected graph, in a directed graph, edges have a direction. We do not set the reverse edges because the connection goes only one way. Third step is update the matrix. Look at the example. There is an edges from vertex 1 to vertex 0. So we set mat 1 0 equal 1. There is an edges from vertex 2 to vertex 0. So we set mat 2 0 equal 1. There is an edges from vertex 1 to vertex 2. So we set mat 1 2 equal 1. Now the adjacency matrix represent all the directed connections clearly. Fourth step is visualize. On the slide, the graph diagram shows the directed edges. The matrix table shows the same connection in the numbers 0 0 0, 1 0 1, 1 0 0. In fifth step is code representation. Here's how the Java code works. We create a 2D array of size n into n. For n vertex, initially we filled it with zeros. Then for each edge, we set mat source into destinations equal 1. Finally, we print the matrix to see all the connections. This Java code directly builds the adjacency matrix for the direction graph. Now let's see an animated example to understand this better. Look at the main characteristics of the adjacency matrix. First one is the size of the matrix depends on the number of vertex in the graph. Second one is the edges of the graph are shown as values in the matrix. For unweighted graph, those values are either 0 or 1. Third one is if a graph has only few edges, the matrix will be sparse, meaning most of its values are 0. Now let's see important applications of adjacency matrix. First one is graph algorithm. Many graph algorithms use adjacency matrix to find shortest path between nodes. Second one is image processing. In image processing, adjacency matrix represent the relationship between pixels, helping analyze images efficiently. Third one is finding the shortest path. By performing matrix operations on an adjacency matrix, we can calculate the shortest path between any two nodes in a graph. Let's look at the advantages of adjacency matrix. First one is an adjacency matrix is a simple and easy to understand. Second one is adding or removing edges from the graph is quick and easy. Third one is it allows constant time to access, check if an edge exists between any two nodes. Now let's see the disadvantages of using an adjacency matrix. First one is it is inefficient in terms of space or space graph because it uses 0n² memories even if there are very few edges. Second one is finding all the neighbors of a vertex takes 0n time, which can be slow for large graph. And that's all for today. We have learned so many things in this video. Adjacency matrices are simple, powerful and widely used, especially in graph algorithms and image processing. Try to creating your own adjacency matrix with different graph to practices. Thank you for watching. Do not forget to like, subscribe and turn on the notification bell. See you in the next video.